Hello, everyone. So today we're going to be presenting a couple of cool tricks and stuff in Matlab, such as how to make graphs look nice and other cool tricks that I'll show you that you can use in your practical assignments. From recalling from last week's lecture, last week's Zoom call, we did the assignment, the first assignment, and we looked at generating signals. Just have fun typing in numbers and seeing pretty graphs. So let's go over that right now. Just a really brief recap. We have our n interval from -5 to 5, increments of 1. We created a delta, Kronecker delta, and this is what it would look like. And you'd be like, oh, okay, let's generate some stuff. Actually, yep, generate some stuff. Let me just do a quick command. There's a command. So suppose you see all this workspace and you're like, oh my gosh, David's been doing some stuff behind doors. Yes, I have. But if you wanted to get rid of all this, there's a couple commands you can do. You can do clear variables. And this command right here just does the following. Enter. Boom. Clears everything. And you don't have to do it all the time in the command window. You can actually do this right here. So let's generate this signal and this signal, and it popped out a cool thing. So usually what I like to do when starting a new assignment is oh, you can't see my face, there you go, is I always at the beginning I always have, close all. So I would do the following: close all, which just says to close all windows. So this is going to close figures, and then clear all will clear everything. So everything that you have in Matlab. But a better command that you could do is clear variables, so that it just wipes right here. It just wipes the workspace clean. So if you want to run that, good, because as you can see, I have other assignments that I like to do, and I don't want to mix these variables here. Here's a good thing: if you want to run multiple programs or bridge other programs, variables that you create here, actually I'll show you a quick example. This is antenna theory. So let's see if I can generate a signal on this homework. Let's call it A is equal to 3 to some complex numbers, or I don't know, 100 to 100. So this right here, oops, what did I do? There you go. This right here will create a vector right there. However, when I go to this program, suppose you're like, oh, I'm just gonna do whatever, and you just call A or something like that. Let's run this section. As you can see, it calls it, and let's say you were going to do B is equal to A. Even though A is not in my MATLAB, it's saved in my workspace because of a previous program. So be very mindful if you're trying to create multiple files. They do link to each other, so that could be a plus or a minus depending on what your purposes are. So always clear variables, always at the beginning of a program, or if you want to, you can do clear variables after every section if you want. Well, this is not a section. I can do the following: clear variables. Like here's one section, like exercise 1, and then you can do exercise 4, clear vary. Like you can do that. In terms of the whole assignments, it's maybe not be necessary if you know where everything is. You don't have to do this, but if you want to be picky and you want to know exactly where everything is, you can use clear variables after a section if you would like. It's all a preference and a choice. But point is, always have this in the beginning. So this goes away. Clear variables. So what we did was we created an n vector and a little thing right here. So this is our Kronecker delta, and we also created a unit step, and we also did some cool colors. And suppose you're like, oh, okay, so now we have all these figures. Now what do I do to make them look pretty? So as you can already see, this one here is red, and this one right here is like, you know, stale and whatever, but it's fine. But this one looks clear. So what I did right there was this following command was to make it colorful. We will use this little command right here, or this little text. I'll just copy this. We're going to modify our delta function. And you're probably asking, where did I get these colors from? And you're like, oh, and what I was going to say is you get them on Matlab. So if you want to go to a new Google page, this will be your best friend. Go to Matlab colors list, and boom, it tells you. So you have many choices of letters, and aha, there it is. So these are what you can use. I think you can also do this, and then you can have multiple colors, but B, K, R, G, and now you can make really nice colorful graphs. So let's make it, I don't know, green. So G, run following, boom, green. But now it looks too small and you can barely see that. So let's make it thicker using line width. I would recommend doing line width because it's easier for me to see it and then easy for me to grade it. So we're gonna make that thick. There we go. But then you're like, oh, I have a OCD, and you're like, oh, you see this dot right there? Maybe it could be picky, and you want to get rid of it. Let's put filled. And the question is, does the order matter? I don't know. Let's try that out. Oh, it does. Yep, it does. So, let's get rid of this. Let's put it right there. Yeah, Matlab likes barking a lot. So you'll have fun with it. And boom, the holes are filled. So that's how you make your graphs look pretty. It's really nice to know that. And so those were the two first things you have to do for the assignment. Oh, what's this? What was that? It's okay. So that's what I required for the first assignment. Exercise 4, I'm not going to necessarily do it, but I'll do a short example, which can lead to the real example, but I'll make sure you guys do that on your own. So the first thing is to make a couple of things. So I call this one Dirac, but it's a chronometer. But point is, let's use it as like no copying, everyone. So what we did right here was I created a new interval. The interval is from -25 to 25, but I'm going to do a really small interval for an example. You generate your signal, Dirac, and your unit, and I created two new functions. Kind of want to see what they look like. So let's do it the fun way. Let's evaluate section, and boom, actually we haven't done anything, they just popped up here. And let's create these functions right here. And what they did was we took this n vector and we just scaled it. So one of them is going to be divided by 2 and the other one's going to be multiplied by 2. And we use our little scalar elemental division and elemental multiplication. And now you're like, oh, well, now I want to see stuff. So if you want to see stuff, let's do figure 3, run section, and it should be here. There we go. There you go. That is our little delta function, -3 to 3. Looks pretty good. And let's generate 4. Run section. Popped up right here. And there we go. That's our unit step 0. Cool. And now let's generate 9. And look, that's our little thingy. And this is function 2. It's really nice to look at this data. And there we go. So now we have 4 signals. And then you're like, man, this is a whole bunch of plots. They're pretty huge. And they even cover my face. So this is cool little function. So I organize it like this. It's called the subplot function. And it does exactly what you think it does. So it just creates subplots. So instead of using figure 4, 5, 6, 3, let's erase this. And you're probably going, no, what are you doing? Don't worry, we'll get there. And let's replace where they are with subplot. Yeah, let's put that there. Let's do it. The first one, subplot. So subplot is asking for an m by n matrix. So m being how many rows, how many columns, and then the position in reference with that square. So right now we have four functions. So that means we would want a 2 by 2 square. So, or you can do a 1 by 4 or 4 by 1, and then you would have to know the positions. So for me, let's do a 2 by 2 square. So a 2 by 2 square, and the first plot's going to be on position 1. So that means this one's going to be on position 1. If you don't believe me, let's run. Oh, wait, don't run section. Evaluate section. There you go. And look at that. Pretty cute, right? And now let's proceed to put this guy right there too. And position 2. So this one's going to be in position 2. And you're asking, where's position 2? Is it here or here? Well, let's find out. Oh, don't run section. So there it is. And then we can make this one position 3. Wait, there we go. Subplot 2 by 2 square, and position 3. And because I'm a little lazy, boom, 4. And now we have everything, and now it's easier to look at, so, and easier to grade too. So very useful to know. The first assignment, we're not really doing any comparisons. I'm just asking for big plots. So I think the second assignment's going to be asking you for subplots. But this is what you would do. And here's an advanced trick. So suppose you're like, okay, I like these squares, but I kind of want different sizes. So there's a way to do that. So, and you have to play with Matlab, and you have to think like an engineer. So what I want to do is I want to make function 1 like a big rectangle in the middle. So that means I would need like maybe a 1 here and maybe 3 rows. Actually, let me try it. So what I'm gonna do is, let's do a 3 by 2. So we're gonna have 3 rows to make the graph a little smaller. It's gonna be 2 columns. Position 1. Let's do this. This is all experiment. I don't know if it's gonna work. So this one's gonna be position 2, and then I want the middle graph to be F1. So we're gonna do a 3 by 1. So this one basically says we divide the figure into 1, 2, 3 sections. So all the figures get divided by 3. And then the 1 just basically says we have 1 big column instead of like 2 or 3 or whatever small. But because we're doing a 3 by 1, the position would not be 1, 2, 3. It would be 1, 2, 3. It's a crazy mind play, but you'll see. So 1, 2, so position 2, because we want to see this one be a big fat rectangle. And this one right here, okay, let's just do it. 3 by 1 and position 3. And let's see the result. Ooh, pretty. See, now we have that. But you're like, okay, let's do... No, I don't think so. That's gonna work. But point is, this is what you can do. Let's do a 2 by 2. Let's try this. Position 3. I don't think so. It's gonna run. Yeah, it's not gonna run because it overlaps. So make sure you think of your sizes. So this one is bigger than this one. They cross, so it doesn't work. So it's just a lot of playing with numbers. That's the thing I like about Matlab. You can make stuff look really nice. And so that's how you combine. That's how you use the subplot function. Very, very nice. And now let's do 5C. So example 5. We're not going to do the whole thing, but we're going to try and do it. So am I recording? Yep, I'm recording. Cool. So 5C, and I have the assignment on me, says we're trying to create new signals with our old signals. So 5C basically says we are shifting 5, so or delaying. So in practical terms, a delay is basically something that just, well, it delays. So you have a signal that comes in, and then maybe 5 seconds later a delay comes out. So 5C basically says our unit step is going to be delayed by 5 positions. So there's 2 ways of doing it. 2 ways. And you can make your life easier, hard, whatever you want, whatever feels comfortable for you. You can either do this, which is, it's cool. So what I did here is, where did I get these numbers? So I'm referencing this unit step. So this is my reference. So we're delaying 5, so -3, so 2, 1, 0, 1, 2. See? And then 3 plus 5 is 8. So that's where I got those bounds. But you're like, that's a lot of counting. So there's another easier way to do it. You can have a dedicated delay or some type of variable that you can change easily. And we're just moving the beginning and the end by the same amount, by 5. So we have this delay, same amount. And I don't know what the beginning of my vector was. So here's n, and our n was labeled this n. So we're taking the first point of n, and we want the last point. Oh, why is it doing this? There you go. Go away. And we want the last point of n. So to do that, you would have to do n position 1 and n position n. These are probably the most useful parameters you can ever use for like matrix analyzation. Beginning and the end. You want to know where you started and where you're ending. So very useful. So let's generate this signal right here. Do this F9. So this generates that, or you can do the cool function F9. Suppress. There we go. F9. Boom, does the same thing. So very nice to have little variables that you can tweak them in the beginning. You don't have to do all these math calcs like, oh, I messed up. So I would strongly recommend trying to do this kind of format where you have variables. Always declare variables. Don't punch in numbers in the end. It's a nice technique. And now we want to shift. So what I did was a time shift. You can also do like an array shift, but that would be a little difficult. But look, this is literally it. The only thing that's shifted is time. So you want to see it? Let's pop this bad boy out. Oh, and you're probably looking at this and you're like, oh, what's this? Let's run that. F9. And here's that little figure. And you're like, whoa, what is this? So this is basically the equation generator. It's the LaTeX format of like equations. So you see all those like big textbooks and they have like fancy equations like f of x. Now you can have these fancy things. So what we do is we stamp this interpreter and LaTeX. So we want the LaTeX library and we want to apply it to our title. So what I did here was the following. I did this, the $sign, the $sign symbols just say, okay, the first one says this is the beginning of our LaTeX, and then we have a second one. It's the end. So it's basically like the LaTeX quote marks or things that just box. So this whole thing will be LaTeX. And then, boom, you get this fancy LaTeX right here. So that's how you do it. If you don't want to see that, you can actually, if you do this, if you just don't put the interpreter, it actually won't interpret. So keep that in mind. Control Z. And now let's look at this guy, the original function. So what I had here was a shifted unit step, and this one's the original. let's run that F9, and that should be right here. And you're like saying, whoa, funny text. And yes, you can change the font using the font name label right here, the font name. So this basically says, okay, what font name do you want? And then you're like, what fonts could I use? So where do you find that? Go to, let's pull this out. Matlab font name list, I think. List, and that is literally it. And I think, oh, list fonts. Okay, actually, let's try that. List fonts. List fonts. Ooh. And you can copy all these fonts. These are all available. And where's Comic Sans? Sans, whatever you like to call it. There it is. So these are libraries you can use, and you can have pretty graphs. And that's how you generate that. And okay, let's go back to one thing. You see this? It's a small title, very small. And you're saying, I want to make this title bigger. So there's a way. And let's go to the back right here. Let's copy these two. And there's a function, there's a label called, or a command called the GCA, which basically just says the current graph. And where's our current graph? This is the current graph. So this basically says, okay, our axis that we want to modify is the current graph that we're on. So for this one, it would be figure 7. So this basically says we're ready to modify it. And okay, let's modify the font size. So ax.font size is equal to 12. So we're just changing the font to 12. And let's run that. And boom, the font's bigger. So if you don't believe me, let's do 14, because maybe you can't see it or I can't see it. It's okay. So F9. Pretty cool. Let's pull that again. And let's 20 it. F9. Boom. And then you see everything gets bigger. So let's go back to 12 because that was a nice number. F9. So now you have bigger graph or bigger titles and labels too. And there's other things you can do too. So one thing that you could do if you really have a OCD like me, OCPD is what he calls it. It's okay. Is turning on grids. So this basically says, okay, we're going to turn the grid on for figure 7. So watch what this does. F9. Ooh, see that? But you're saying now it's too small. I can't see that. Whoa. Now let's make it bigger. Using line width. Copy. Actually, no. Copy. And there we go. The line width of the grid. F9. Ooh, everything looks nice. Actually, what does it do? 3. Let's try that. F9. See, it makes everything look bigger, and now you're like, I can point. So that's a really nice thing to do. You can have lots of pretty graphs. And then I have this right here. And this will right here will set the graph color, like the color of your figure to whatever you declare it, I think. And I put it as white because I want to have a white piece of paper. I want to print it on a white piece of paper. So the default is gray, as you can see. You're probably saying, like, what do you mean gray? I'll show you. Ooh, now it looks white. Now you can copy paste this to your Word documents. But there's another technique I'll show you. So there you go. That's a really nice plot. And you're like, oh, let's actually make that font line width bigger. Line width 3. Let's run that. Oh no, that's It's the title. It's the title. We need to do the stem. There we go. Now you can see it. Pretty, right? So now you can have pretty graphs, and this is a function. I was like, okay, you can do this to all your plots. Watch this. Let's copy this. And here's figure 8, and you're like, I want to make this one pretty too. Oh, girl, you want it? You got it. Oh, F9. Yeah. Well, that's a lot of type, and it'd make your code too big. So let's introduce you to functions. Functions are your best friend. The function I create is called Pretty Graph, and I've used it since 360. Every class I've used it. Power, electromagnetics, even circuits. 700 classes. I always have this little pocket function. So let's show you what I mean. So let's create a function. That's a useful command right here. You see these quotes? We can do uncomment or comment. If you want to comment this again, you can, which is Control R, or you can uncomment, which is Control T. I'll do Control T again. Uncomments. So we're going to create a function. So function, the function. What's a function? Just kidding. Is basically a label that just says, okay, we're ready to call a function or label a function. Function pretty graph. So this is what I do. Then it adds this. And then to close the function, let's put end, and that closes the function. Now you can open it as a book. And then you can comment stuff and say this creates pretty graphs. And let's get rid of. Why does this window pop up? No, you can. Okay, this is our daily advertisement, side advertisements. Okay, point is, now we have a pretty graph function. So let's run that. Maybe it'll run in the background. And now let's go here. So instead of doing this, actually, let's take this off to show you what I mean. So, boom, now your functions look ugly. And now you're like, not over here, we have pretty graph. It makes it like it's just a big fat variable with extra steps if you think about it. So this is storing all this information. So this is basically like a passive function. It just has a bunch of stuff. It's basically just a bunch of commands. So I love using this. And then let's run that. Boom. Really small code, efficient, and it's easy. And yeah, pretty graph. So that's very, very useful to use. And now let's talk about a cool thing about Matlab. So suppose you see these unit steps, right? And you're like, they look pretty cool, but I kind of want to even go further and look at them like even closer. So we can actually plot these in the same thing, the same plot. So right here I have a new figure. We're just going to call those functions again. And there's a function called hold. And this basically holds data or holds stuff. In this case, we're holding a plot. We're holding a figure's information. So figure hold on. And then it says, okay, holding on, and then hold off. Make sure you hold off. If you don't, you have a whole bunch of stuff in one figure. So do remember that. So let's see that. And that popped up right here. And note that n and ne2, we've declared them as, so n right here is -3 to 3, and ne1 or ne2 is from 2 to 8. They're different. They're different increments. And MATLAB can deal with them. They can say, okay, we're just going to look at the lowest point and the maximum point to make sure they all fit. So do keep that in mind too, but make sure they're that at least the stem functions are called correctly. So that's really good to have. And now you can have two plots and you're like, suppose, well, actually, before that, you probably see this little subtitle. To call a subtitle, So let me just do this. So let me try something cool. So let's Control X. So as you can see, you can do title, right? So title, let's run section, title, right? So this first parameter is always your title. So actually, let me do this. T1 or something like that is equal to this. Let me try this. I don't know if this is actually going to work. I don't think so. Or this is all one big title, and let me do that. Let's see if this runs. It actually runs. I'm actually surprised. So, okay, point is, you can do this. So what you have to do is you have to have your first item in this big array, this clump of array, is going to be your big title. And then this one right here is going to be your mini title. And as you can see, I've used LaTeX little dollar signs. Make sure you have this too. So the way I usually do titles, now that I'll probably do titles, is copy. I usually put these little squiggly lines to create that subtitle. Does the same thing too. And now you're like, okay, suppose you're like, well, not dumb, but saying, oh man, I have this graph here, and which one is which one's you, oh man, oof. So there's this thing called the legend. So legend, let's do it right here. Actually, you can do it after, hold off, doesn't matter where. Legend, the legend function just creates a legend. So the first parameter is your first label, as you can see right there, label 1 to ... label n. So let's create the first thing we plotted was the shifted one. So it goes by order, so it labels by the order of whatever's the first hold on plot. So this was the first one. This is the shifted U of n. So U of n. And then the second one was U. Actually, no, sorry, what am I doing? N minus 5. This one was shifted by 5. And then this one's the original signal. U of n. So this is our original plot. And now let's run that. And boom, now we have a little legend. And now actually they're not the same colors because I'm always instantiating. Hold on, let's close that. And it popped up right here. Boom, perfect. Because we want to see cool graphs. So go to line width, copy, paste, pretty graph. And let's close this to refresh it. And there it goes. Magic, cool, right? And now you're like saying, this bothers me. You can move it, but you want the code to move it for you. So we can do this. Let me see if I can remember it. The location, and we want it on the, I want to put it right here. There's specific values. You can look at this up via Google. Just type in Matlab legend. And boom, you can add legend to axis, and I think it tells you locations. So like if you want a specific location, I'm gonna do general locations. Yeah, I think this position. But point is, I'm gonna show you what I'm gonna do. So location, I'm gonna put it in the northwest. So northwest. Let's run that. Boom. There we go. Let's close that again. Northwest. And there you go. So that's how you use legends, and now you have a really pretty graph. You have really nice plots. And oh, if you want, you can also change the labels too. Let's change this thing to value, font name, comic. It's just all an art. So I do tell you everyone to just have fun with MATLAB. You'll you'll love doing so many crazy functions. Uh, the only limitation is your imagination and the time that you have. So do have fun. And now we're done. We have really pretty graphs. And now you're like, okay, time to submit it to me or to David. And you're like, oh, should I open a Word document? There's a function called the publish function. There's two ways of doing it, but I'm going to show you the practical way. And that's right here, publish. So you don't have to create a Word document, but you could. There's two ways that you can do. I'll give you paths, but your end game is to make sure it's a PDF. If it's not a PDF, I will dock a point off, but make sure it's a PDF in the end. I don't really mind what you do, but make sure it's a PDF. So I'll show you what I usually do. So publish, edit publishing options, and then a window pops up, and then you can, here's your title, go to output file format, PDF. That's it. And then you can publish that. But before we do, note that you see some stuff right here, right? You see this window that's running out. Make sure you please try to suppress some stuff that I don't want to like really see. Like, and I'll tell you right here, like, oh, you forgot to suppress this. Because if you don't suppress it, it prints it out unless you want it to print. Like I'm asking for a value, like, oh, what's the value of position 3? Then you can do this. So actually, let me do quick exercise. Tell me voltage. So V is equal to from, I don't know, 1, 2, 3, and then I ask voltage of position 2. So you can either do this V2 or V2, which is in position 2 right here. So this will just output 2. F9, position 2, or actually let's change this to 0.1, 0.2, 0.3. So let's run this section, and there you go, 0.2. But if you want to write text, let's get rid of this. Okay. If you want to write text, you can do the display or disp function. That this function is, okay, we're going to display an answer. So we're going to display as a string the voltage of position 2 is, and let's do this %. I think it's $D. I think it is. Your position, and then let's end that comment, and then we're gonna have to say V2, and let's see what this does. Oh, and that value must be a character, vector, or a string. Oh, this is the wrong one. Fprint. F. This will let you do all that stuff. So this is the print statement, sorry. There you go, and boom. And to make sure you have an enter, I think that command is /n, I think. Yep, it indents. Cool. Actually, let's do it again to show you I'm not crazy. There you go. Now it creates 2 intervals, so don't forget this. And now you can have 2, and they're like, hey, that doesn't look right. You can do F 4.1. There you go. Now it looks better. So this basically says we're gonna have 1 decimal point, and we want 4 significant figures to the left side. So we'll have 1, 2, 3, 4, 1, 2, 3, 4 positions and 1 decimal. So you can do that too. So now you can have really pretty statements. So fprintf is another function you can look into. That's where I got these things. So you can look at the precisions, exponentials, and whatever things you want to do. Now everything's ready. Make sure you suppress stuff. Suppress, please suppress. I'm not going to read all those characters. You might have a huge vector that prints out. It's not going to be nice to look at 30 pages of stuff. Please don't do that to me. Like for here, I'm looking for a graph. Like, actually, oops, declared a different end. So right here, I'm looking for a graph. I'm not looking for this. You see this n right here? I'm not gonna look for that. I'll look at it right here. Please suppress it. For the first assignment, I'm not gonna go crazy, but the next couple of assignments you'll have n goes from 1,000 minus 1,000 to 1,000. You're gonna have 1,000 characters, 1,000 lines. That's a lot of garbage that I have to look at and be like, whoa, you're wasting paper. So make sure you suppress, please. It'd be nice to save some trees or electronic trees. Suppress, and don't worry about that. But it's barking at me because it wants these types of brackets, these square brackets. And what's this? And boom, you have no errors. This thing says no warnings. You're ready to run the whole thing, and there you go. So now let's publish. Finally, let's use the publish function. Edit publishing. Go here, PDF, publish. And that's it. That is how you publish the first assignment. And just let it do its thing in the background, and boom. Pretty cool. Huh. I'm not getting that big title in the beginning. So that should be on the top. So this is your publishing thing. If you want to make it more nicer, I'm going to do what I do. That's because I didn't do this. To create a big title, make sure you do this. This is your big title, followed by another statement. I think let's put this. I think that's fine. Let's publish that again. And there we go. Title assignment. And it puts that right there. Make sure you put your name in it. By David. Let's publish it again. And boom. And that puts it right there. So very nice to have. And you have really nice things. It posts all the code. I need to see all the code. So then I know how you generated these. And it looks good, and I'll be like, good, looks good, looks good. Oh, beautiful. Oh, I see your function. And there you go, publish with Matlab. So that's what I want to see too. You don't have to type it, it does it for you. And suppose you're like, I want to edit this. It's okay. Well, you can make it even more prettier if you want to, but that's the requirements that require. Use the PDF. If you can do more modifications, actually, let's do even more modifications. So let's do this. Suppose I type stuff, and here is a text, sentence or equation. X of n. $sign. There we go. And publish. Okay. And then look. Oh, looks really nice. So now you can have even nicer stuff. So yes, you can do latex in your thing. So this right here that I created was a subtitle or a sub sentence. So you can generate a title, and then after that title you can proceed it with some fonts, and then typing, and then presenting. I think you can do this. I don't think so. You can. I think you can do this, and Then, no, that's fine right there. Point is, you can do that too. Let's create a different output. I want to create a Word document, and you can do that by doing doc publish, and it does the same thing too. If you want to edit your things, so going pretty far in this video. Okay. So let it do its thing. And let's just chill out. Oh, there it goes. It published it. And boom, this is the Word format. So yes, I do see how you output it. So this is how I see that you did a Word document, and then the other one is how I see you did Matlab's PDF function. So this is fine. This Word document is okay. The problem is if you turn in a Word document, I will dock points because I don't want to mess anything up. But what you can do, just look at your thing and you're like, oh, I like this. And look, it actually does pretty cool stuff. Okay, looks good, looks good. You're like, okay, looks great. Publish with Matlab. What do you do next? Print or save as PDF. And then you can just do PDF or whatever you want. Because I already have one here. Homework 1, 2, there we go. And there you go. That's a PDF, and you can submit that. So that's another way you can submit stuff. So make sure the end game file is at least a PDF. I don't mind what you use. You can even do HTML to PDF. As long as I see a PDF, looks fine. So this should get you ready with the first assignment. This was a whole lot of stuff. So I know it's a lot, but you'll have some fun. The next assignments won't be that bad. But right here is all the basic stuff that you need to know. So if you have any questions, please email me, let me know, and we'll talk about other functions or anything else you want to learn. But this is the practical stuff, everything you might use and everything you possibly will use for your future assignments. So let me know. All right. And with that, I'll be signing off. And thank you for watching this exclusive Matlab video. So take care.